Okay, welcome. So what we're going to do is we're going to unpack ladder logic, specifically about a holding circuit. And we've got a tank here, and we've got some things. What's going on is that we've got my upper float switch and my lower float switch, and they're going to open and close depending on where the liquid is. Also, I have a temperature sensor. We can add that in if we want, or maybe not. I've got a motor here, some kind of pump that's pumping liquid in here, and I've also got a drain that's draining out. The symbol I'm going to use for my drain is a solenoid. And the symbol I'm going to use for the motor is just a motor. So that is the symbol I'm going to use in my ladder logic for the motor. And this is a solenoid. A solenoid is a cool device. It's an electromagnet. You turn an electromagnet, creates a magnetic field, so it pulls something. Or we can get them to push things too. So what it's going to do is it's going to pull a valve open. And we won't even get into how that works. We'll talk about that later. Actually, you'll talk about that in pneumatics. But for now, we're just going to believe if I turn this solenoid off, I energize the solenoid, it actually opens this valve and lets fluid go out. What we want to do is we want to have a start button that when I press start, it fills the tank. That motor's going to come on and it's going to fill the tank. And then when it gets filled, when it gets full, it's going to empty. Okay, there we go. That's it. So there's also another stipulation. Maybe we're going to have this on automatic a little bit later where I press play, it fills and empties, then it fills and empties back and forth and back and forth and back and forth. Maybe we could put a timer in there, which we'll talk about next week. Timers, maybe fill up and hold it for a while and then empty it. But for now, we're going to work on what does it look like when I press a button and it fills, and then it fills and then it drains. What I'm going to say is for our initial event, for the initial event that makes this start to fill, we're going to have an and. We're going to have it so that it must be empty, and I have to press the start. So when we're talking about event programming, now if you watch that video when I was talking about holding circuits, and if you haven't, please just get on that. I talked about events a lot. So I need you to think about events. I need you to think event programming. So we're going to talk about events. What's the event here? If you're talking about an event, don't say anything electrical, nothing. An event is just something that happened. Window open, window closed, the level went up, the level went down, the temperature went up, the temperature changed, somebody pressed a button. Yeah. So that's what I need to think of, event programming. So as far as the events go, what two events have to happen together to make this start to fill? One is that it's empty, and the other is that someone pressed the start button. Okay, so those have to be true for this pump to come on. We're going to see that creates a problem. Let's take a look at it. Let's just start. You don't know what you're talking about? Like when you're doing ladder logic, just start. And if you really do, if you have a whiteboard, dude, it's awesome. You can erase. But that's what I'm saying is, you have a whiteboard, get a piece of paper and a pencil. It's really easy to erase. You'll end up erasing a lot. I erase a lot. I'll probably do that as I do this because I'll be like, oh yeah, it doesn't work. Okay, here we go. So for me to start my ladder logic, I'm actually going to start it here. So that's 24 volts. I'm going to start a rail here, and I'm going to put another rail here that's 0. Okay, good. So I've got these going on here. Now, I know that if I'm going to use a start button, I need a holding circuit because it's a momentary contact. So this is our first holding circuit. So essentially what's going on here is I'm going to do this. I'm going to put a stop button in here. And the stop button is a normally closed button. And when you draw that, you physically have to touch this. And then I'm going to come over here, and I'm going to draw a start button, which is a normally open button. And then over here, I'm going to drive a relay. Now, we know that that's just the relay coil itself. It's not the actual relay. Let me get a relay. I was looking actually for a really big relay that I have. Whatever, it's somewhere, but it's not exactly right. I thought it was, but that's fine. So here I go. I've got a package of relays here. So what's going on is if we look at this relay, what's happening is that there are these contacts. And this is actually the same relay, the same model of relay that you'll have in the modules at school, except that I pulled this out of an old timer circuit. Anyway, what's going on is that if you look in here, let me just see if I can, I just want to make sure I can focus in on that. Oh, yeah, you can see that. So see that white part in there? That's actually the solenoid itself. That's the electromagnet itself. And then those things on the side are contacts. So if you see the things down here, down there, Those are the contacts. And there's that thing that moves back and forth between the contacts. There's a contact over here. And look, there's a contact over here too. So this has a common, which is that strip there. So the common's up here. There's a common there and a common there. And then it's got a normally open and a normally closed. So this has two contacts, and a contact has a normally open and a normally closed. So that white thing in there is actually this. That's what the white thing is. It's actually a solenoid. It's an electromagnet. It's a solenoid. So what's going on is that thing energizes and it moves those contacts. And we represent the contacts. I mean, I'm not telling you that you don't already know because you didn't study everything for lab 3. Okay, so let's continue here. What we've got here is if I wanted to, I could do this. I could put this here and I could call that R1-1. And over here, I could put my motor. Okay, so this is pretty simple. It's not going to work, but it's kind of our first step. Again, we can make changes. So if I press this, and this becomes closed, power goes from here to my motor, and my motor starts putting liquid in here. Okay, so but the problem is I have to physically hold the button the whole time, because as soon as I release that, this becomes open and the current doesn't go through. So what do? I use a holding circuit. Now, this is just, I can't even stop and tell you how cool it is. I'm just going to roll with it because you have to watch that video about me explaining it. But what I'm saying here is that I'm going to make this R2. And I'm going to take this and put this here. This is my holding contact, R1-2. Now, R1-1. What happens is I close this, this energizes, this becomes closed, the motor comes on. When I release this, this stays energized because that's closed. So this is associated with this. So when this electromagnet energizes, it closes this. So now I've got current going here and here because I have my finger on the button. When I release the button, the current stays going. It holds the solenoid, so it holds the coil, this coil energized. It's remarkable. I have a holding circuit. So this momentary contact, that momentary event of me pressing the button and then lifting my finger, the event goes away. So what's happening here is that goes away, but this is held and that remains closed and the motor comes on. Okay, so but the operational parameters that I said in the beginning were the event that starts the filling is not just one event. There are two events that start the filling. One is someone has to press the button. The other is the tank has to be empty. So if I press fill and it wasn't empty, it was halfway, it wouldn't fill. Unless it was already filling. Let's go ahead and do that. What I'm going to do is I'm going to add logic here because what I'm saying is if it's empty and I press the button, remember an and is a series connection. So if it's empty and I press the button, then this comes on and it stays on until that gets up to here. Okay, so what I need to do is I need to use this information that tells me it's empty. Now, this is going to be open. So what I do is I'm going to draw this here. And I'm going to draw, this is actually a level switch. A float switch looks differently. So upper level switch, lower level switch. A float switch actually looks different, but it doesn't matter. So I'm going to take this and I'm going to put this over here and I'm going to put that into R2. Now the problem is I want to allow the pump to come on if this is open. What do? Well, I know I can reverse logic with a relay. So I drive this. So this is my lower level switch. So I drive this relay coil with this. So now I have contacts in here that I can use throughout here. So you know what? I'm going to put one of the contacts right here. And this is from the lower level switch. Now, this is actually going to be called R2-1. Now, I have to consider whether it should be normally open or normally closed. And to do that, you want to stop and do nothing. You want to say, okay, if I haven't pressed start, if I haven't done anything, and my tank is empty, what does it all look like? Well, if I haven't pressed start, that's open, that's not energized. Is this open? Is this energized or not? Well, it's empty, so that's down. So actually, this is open. So that's open too. My logic to make this fill is if it's empty and someone presses the button. So if I were to press this button, that would become closed, that would become closed. It still wouldn't come on because this is open. So what do? I make it a normally closed. So now, again, I don't do anything. I just stop and I say, okay, what's happening if I don't touch anything? Okay, I'm assuming it's empty. Don't touch anything. That's open, that's de-energized. That's not on, that's de-energized. And this guy is closed because this is open. Therefore, that's in its normal state, and this normally closed contact is in its normal state, which is closed. So it's closed. Okay, good. So what happens if I press play here? Okay, that closes, this closes, and guess what? The motor comes on. All right. When I release my finger from here, this keeps this energized, and this remains closed, and this remains closed, and my motor stays on. Perfect. Okay, good. So we're done. It's perfect, right? Maybe not. Hey, does anyone see an issue? Let me ask you a question. Is the tank going to fill? I want yeses and nos. I'm going to go watch. What do we got? Who thinks the tank's going to fill and who thinks it's not? Yes, okay. Who thinks it's not? Daniel thinks it yes. I'm waiting till someone else says something, or else I'm just gonna leave. Okay, yes. Jack says yes. Okay, someone say no, just for fun. Just for fun. Just for fun. All right, no. Okay, Jack is right and wrong. All right, I love it. Duality. Watch this. There's a problem. The problem is this, dude. Guess what? When the liquid, I'm going to use blue for my liquid. Okay, here we go. So the liquid comes out of here, goes down here, and it fills up to here. Now remember, this is not energized yet, so this drain is not on. That's fine. Liquid gets to here, and then it starts to fill. Liquid goes to here. When the liquid gets to this point right here, so let's call that point 1. When the liquid gets to point 1, what happens to this switch? And it closes. Okay. If that closes, then that energizes. This becomes open. Is that true? Yeah. So the pump's going to stop. See it? Let's just go over this again. Okay, my liquid's going up and up and up and up and up. It gets to here. This becomes closed. This energizes. This normally closed contact becomes open. Because normally it's closed. But if you energize this, it goes into its active state, which is open. So this becomes open and the motor stops. Let me shut my window so we don't hear the trucks. The truck. Okay, good. So I think we get that there's a problem here. So what I need to do is, there's a signal that told me that a signal said, hey, you know what? You can go ahead because I've just got an event. The event is that the tank became empty. So again, going back, the two events that make this happen is that one is somebody presses the button. The other event is that the tank became empty. All right. So, but the thing is, that event, one of those disappears. Me removing my finger from the start button disappears. Well, the other thing is the other event is the tank is empty. It also disappears. So both of those are momentary events. They give us momentary signals. One's a little longer than the other. I mean, the momentary signal from here is this long, right? Like it's quick. But this guy, I don't know, maybe it depends how big the tank is. This signal, the signal is, okay, I'm low, right? The event is tank's low. This switch or sensor, in this case it's a switch, says, hey, tank's low. Or it actually can say, hey, the level of the tank is of me. It can't say it's full, but it can say, it can tell you two things. One is tank's low. The other is it can tell you the level's above me. That's all it can tell you. So what's going on is that the two events came and went. The first event, the second event, low. Now that low event's gone. So how we managed that was that first event that was momentary, we put a holding circuit around it. we use a holding contact. Yeah, there's some terms here. This is called a holding contact. There we go. This is a holding contact. This is an activation contact. And this is a termination contact. So this is a holding contact. This is an activation. And this is a termination. I can't even spell. Termination contact. Okay, so that's a termination contact. For every holding circuit, you need all three of those. So the activation contact here came from the event of someone pressing the button. The holding contact comes from the relay itself. They always come from the relay itself. And then we always have to put a termination contact, because you know what? If I don't have a termination contact, this holding circuit stays active forever until you physically pull the power from the machine. You don't want to do that. Okay, good. So I think you guys have figured this out. What I need to do is I need to hold on to this momentary signal. So you might think, oh, okay, well, I'm just going to do this. Actually, you can't do that, because the momentary signal has to be high. So when an event happens, you have to get electrical impulse. In this case, when the event happened, we got rid of an electrical impulse. It disappeared. An event is triggered by the disappearing of an electrical impulse, or the electrical circuit knows an event went away, or that event, it knows that the event happened, which in this case is the tank was empty. It knows that happened by the loss of an electrical impulse. So how do we deal with that? We can't actually hold on to the loss of an electrical impulse. There's actually two ways to deal with it. One is I can go and change this to a normally closed level switch, right? So that when the level goes below it, it actually closes. Or I could actually put the holding circuit around here. So let's take a look at those two options. One is I could do this, and I could turn this into, actually, I'll just redraw it. I could do this and turn that actually into a, it's a normally closed contact. So when the liquid comes up, it becomes open. Now, if I did do that, I'd have to remove this. See the logic there? I've just changed this to a normally closed, so I have to change that to a normally open. Because what happens is I want this to become closed when the liquid goes below. So if this is normally closed and I leave it that way, when the liquid goes below, this becomes closed because it goes down. That energizes. This goes into its active state because it's a normally closed contact. Its active state is open. So I have to get rid of this. And I just have to put a normally closed contact, a normally open contact. So that's one way I can deal with it. The other way is that I can actually go back to the normally open here and put my holding circuit around this. Now, if I did do that, if I did put this holding circuit here, and I left that as a normally closed, and I put this back to a normally open, that's okay. But I need to add a relay here, because the holding circuit always holds the contact from the relay it's energizing. So that actually complicates things. So I'm not actually going to add that. I'm going to go back to this. I'm going to go over and I'm going to go back to my supplier, and I'm going to say, you know what, Mr. Supplier, before I actually, you haven't even gone to the supplier yet. You're designing your circuit first before you go to your supplier and order the parts. So what you're going to do is you're going to order a normally closed level switch, because it makes things a lot simpler. Because if you had a normally open level switch, you'd have a normally closed here. You'd have to put a holding circuit around this, and then from there you'd have to add a relay so you can have a holding circuit. Oh, but I don't want to do that. So what I do is I've already got a relay here, so I'm going to use it to hold this, and I'm going to make sure that's a normally open. Okay, so that's going to be R2-1. Sweet. Okay, so no, R2-2, pardon me. R2-2. Now, because I know that when I build holding circuits, which you'll see in that video, in both my videos, or more so in the lab video, you will see that I like to use my R1-1 for my holding circuit always. So what I'm going to do is I'm going to switch this to a 1 and switch this to a 2. I told you at the very beginning I'd be erasing things. Yeah, so use a pencil when you're designing this stuff. Okay, good. So what's going on here is I've got 2 events that are momentary. When they happen, the motor comes on, and the motor has to stay on actually until it gets all the way up here. When it gets up there, the motor's got to turn off. So those 2 events are momentary. One is a button that presses. The other is the fact that this lower float switch only was in its active state, either open or closed, momentarily, like while the tank is. So that goes away as soon as the liquid goes above here. So I have to hold this and I have to hold that. So we've used 2 holding circuits. Now, the liquid's starting to go up. Okay, that's fine. Liquid goes all the way up and it gets to the top. And then what I actually want to do is I want to turn this on. I want to energize this so this drains, and I want to turn that off. Yeah. So what do I do there? Well, I have to do event programming. I have to think to myself, okay, what event is going to make 2 things happen? One is the solenoid to come on, or to energize, to actually turn this valve open so that the fluid goes out. And the other is, actually, I want to stop the motor. So that event has to do 2 things. One is energize that and turn the motor off. Well, how do I turn the motor off? It's actually pretty simple, because the only thing holding the motor on right now is a holding circuit. I can just terminate the holding circuit. So I can use just a contact or an event to easily terminate a holding circuit. Simple. But I need information from that event. So I need some kind of switch or a sensor that tells me that that event has happened. Where do I get that? I think you guys know this. What's the event? Well, the liquid went up. The liquid got to the top. So what switch or sensor will translate that event into an electrical impulse? Yeah, the upper level switch. Okay, good. So I'm going to take my upper level switch and I'm going to put it on here. One thing I'd like to do is I want to figure out my field. I just want to, sorry guys, I'm going to go around here and find out where I'm at. You know what? I might even just, no, I'm okay to roll with this for now. Okay, good. So what I'm going to do is I'm going to sneak this up a little bit. I want to get as much room as I can here. So that's my R2-1. Over here, what I want to do is I want to put my other level switch in here. I'm going to drive a relay with it. Okay, good. So now I'm not even going to draw it normally open and normally closed yet, because I found that last time I ended up changing it. So I'm just going to kind of leave it for now and think about it as I go. But here I'm just going to label it. So this is my upper level switch, and it's either going to be normally open or normally closed. And like I said, I'm going to design all this before I go and order my parts, so I know I have to go later, like, oh man, now I have to order another switch that's normally closed instead. All right, so what I want to do is I want to study the event that actually makes these 2 things happen, and that event is this. Okay, I want to actually ask myself, is that event going to be temporary? You guys tell me, is that a temporary event? Yeah, I think we got a yes, right? Yeah, no, it's not temporary. Okay, no, it's great. I love the answers, dude. I love it. Like, let's be wrong as much as we can. It's much more fun than being right. This isn't a trouble. Trouble's fun. Okay, guys. No, the answer is, yeah, dude, of course it's a temporary event. Because the event is the tank got full. All right, how long does that last for? Well, we know that the operational parameters are the tank empties and then it fills. Sorry, I just said that wrong. The tank fills and then it empties. So the tank fills, that's an event, and then it empties. So that's a momentary event. Okay, here's where actually we need another holding circuit, because the event of it filling is momentary. It just happens actually just for a little bit of time, because the liquid gets up to here. This is 0.2. The liquid gets up to here. And this tells my circuit, hey, it's full, empty, right? So it starts to empty, and then when the liquid gets down to here, well, that signal that told us it was full goes away. But wait a second. I need this signal to tell the circuit empty the tank. Well, is there an if or an and or an or anything here? Well, the logical statement is if tank full, then solenoid. So the problem is that if tank full goes away. So I need a holding circuit for that. So what I'm going to do is I'm going to do two things. One is I'm going to energize this, and I'm going to use a contact over here to de-energize this to turn the motor off. Okay, good. So I'm going to put this guy over here. Now I'm going to put a contact here from R2-3, because I've got R2-1, R2-2, R2-3. Now, 99% of the time, your termination contact is normally closed. Remember, this was a termination contact. That's an activation contact. That's a holding contact. This is another termination contact. 99% of the time, they're normally closed. Now, that means that this guy, we can establish for a couple of reasons. If this should actually be normally open, normally closed, or normally closed, I have to study that. I don't know. I'm just going to put that there. I don't know if it's normally open, normally closed, but I'm guessing it's going to be normally closed. But I have to study this. Am I going to go buy a normally closed or normally open float switch? Well, to think about this. When it's full, I want that switch to give me an electrical impulse. When it's not full, I don't want it to give me an electrical impulse. So if I use a normally open, it's actually better. Watch this. So I'm going to draw this here. So my normally open float switch will become closed when it fills, and then I'm going to get an electrical impulse. Okay, good. That is when this guy is going to energize. So that way I can actually put a holding circuit here, and my holding contact goes from R3-1, and my activation contact is my upper level switch. And my holding contact is this. Oh. No way, dude. I put a holding circuit in with the termination contact. Did it twice. No, there's a mistake. That's why you need an eraser. But you can add them in later. And sometimes kind of what you got to do. You're kind of like, now, get these holding circuits. How do I terminate them? What do I do? You'll figure it out. So let's go through this process. The two things, when this event happens, the two things is that shuts off and this energizes. Okay, so if this energizes and that shuts off, it's easy to shut that off. This energizes, and this needs to open when this energizes. So I need this to become open in this is active state. So do I use it normally open? Well, think about it. Okay, when it's activated, I want that thing to be open. No, I don't want to use a normally open, because a normally open becomes closed when this activates. So I want something that will become open when this activates. So I want something that's normally closed. So there you go. Use a normally closed here. So you put a normally closed contact from this guy here. Now, when this energizes, because of this event closing this switch, this will become into its active state and become open. So terminating this, watch this. Bam, it's like this cascade effect. This guy all of a sudden de-energizes because there's no current going here. It's cut off right here. So therefore, this becomes open and the motor shuts down. Now, this guy remains closed because, you know what? This holding circuit, no matter what, it's still giving me that information. And actually, the tank is up here. So this guy is open. So even if I terminate this, if I terminate this thing will shut down, it'll stay down. So what I'm thinking is that I want to terminate this with some kind of signal. I might as well use the event that it got up, because ultimately, the only reason I'm holding on to this signal is to fill the tank. When I'm done that process, I might as well just kill my holding circuit. So what I'm going to do is I'm going to put another normally closed contact here from my R3-2. Now remember, that's not a holding contact. It's a termination contact. I can use a contact from here or here or here do anything I want. I could terminate something. I could turn something on. I could start a whole other process if I wanted. It's not the holding contact. The holding contact is always here and here, and it has to be associated with the exact same relay that's associated with there. But put another contact from this any other rung, and you can see there's one here as well. So with that said and done, I just dealt with the fact that I built a termination. I built a holding circuit without a termination contact. Got it covered. So now, what's going to happen here? Okay, this guy is now open. This is terminated. This guy is held closed. Oh yeah, I want to turn the solenoid on. So I've turned the motor on. I've turned the motor off. Now I want to turn the solenoid on. So I can do two things. One is I can start a whole new rung and drive the solenoid with another contact from here. Or I can just put the solenoid in parallel. I think I'll do that. So this is going to come down here, go here. This is the solenoid for the drain. Okay, that's a solenoid for the drain. So let me put this here. Okay, good. So now what we've got here is, I know this is heavy, dude. I know I'm throwing a lot at you at once. It's okay. It's a video. You can rewind. Okay, so what's happening here is that at any time, just stop and say, okay, where am I? What contacts are doing what? What events just happened? What's energized? What's not? What's open? What's closed? Okay, well, that's easy. You just do that at any time, especially if you're kind of like, where am I, dude? Well, just pretend that you're somewhere. Okay, so if the tank is completely full, just filled, what's happening? Well, we know that this guy is closed. That guy is actually closed because that's energized. Well, that's energized because that's energized. They're in parallel. This guy is open because that's energized. So therefore, this is terminated. So this is no longer energized. That's no longer closed. And essentially, if I go up to here, this is open right now because that's energized. That's open. Therefore, that's de-energized. If that's de-energized, then all of its contacts are open. So that's open, and there are no other contacts from R2. So therefore, the motor's off. Plus the fact that this termination contact killed this holding circuit because guess what? This guy is open. Yeah, think about it. The fluid's up here. That's a normally closed contact. So if the fluid's above it, it's going to be open. So this is open. So this terminates, or this de-energizes. That's open. So that's kind of where we're at. Now, imagine this. The fluid starts to come down. Well, it does that because this drain is right. It's like that. And we remember that we did put a holding circuit around this because we understood that that is actually going to be a momentary event because it's going to fill and then it's going to start to empty. So when you're doing your programming, think about events, event programming, and then say to yourself, is that event momentary? No, it could be a single pole, single throw switch, and someone just goes and pushes it down. That's not a momentary event. Someone closed the switch, just like your switch for your lights. Someone closed the switch, so you flick the switch on, or you flick the switch up, turns the light on, and that's it. That event is actually continuous. That the switch has been pushed up. Well, it just stays up. But we have a momentary event here with the push button. We have a momentary event here with the liquid going down. We have a momentary event here with the liquid coming out. Those are our three events that we're dealing with. So now the liquid starts to come down. This becomes open. As soon as the liquid gets to here, that becomes open. But this does not de-energize, and neither does this. They stay energized because I have a holding circuit here. This remains open because that remains energized. This remains open because that remains energized. Oh, look at that. This is kind of cool. This is like kind of almost a safety feature. What happens if someone presses the start button? Well, you think, does the motor come on? Well, no. The reason is because this is open. That's going to stay open as long as this holding circuit is there. So obviously I'm going to need a termination signal in there. Okay. So now this is where it gets complicated, and that's fine. I'm just going to keep going complicated. What's happening here is that when it empties, I want it to shut off. Just everything just shut down. Okay. So what event is going to tell me that it's emptied? Well, it emptied. Yeah. Okay. So what electrical impulse, which switch or sensor, because an event comes from a switch or sensor, which switch or sensor translated the event, it's empty, into an electrical impulse? Well, yeah, the lower float switch, yeah, for sure. So this guy is going to become closed. It's going to tell us, it's going to give us the event that this guy has emptied. And then from there, I can terminate this. The problem is I've only got one of these. I can't put this in two places. So if I did do that, then I would terminate this and everything would be off. It would be just fine. Then I could start the process again. If I press play, it's empty, and the two events for it to fill is that one is empty and the other is someone pressed the button. But the thing is, I can't. There's only one of these. I only bought one of these. I could go buy another and put two of them here if I wanted. And use it here. How do I multiply a signal from a switch or a sensor with a relay? So I'm just going to go over here. Hold on a second here. I don't have very much room. I'm going to go down here, dude. Sorry, just give me a sec. Sorry. I'm going to multiply the signal from this with a relay, which means that I actually have to remove that and drive a whole new rung with a relay. Now, this is where we have to do some thinking. It's okay, step at a time. Now, I don't care where I'm at in the cycle right now. All I know is that I need to multiply this. I need two of these signals. So I'm going to put one down here. I'm going to take this guy and I'm going to put him into here. And then I'm going to put this here, and I'm going to drive another relay, R4. Okay, good. Now, this can either be a normally open or a normally closed. I'm going to stick with the normally closed because we kind of went with this. So I'm going to say this is my lower level switch, and I'm going to remove it from here. And I'm actually going to put a contact in here from R4 instead. Okay, this is from. So this contact, the information that drives this contact comes from this lower level switch. So it's relayed up into here with this relay. Okay, good. So now I have this information and I can double it. So I can take the information I'm getting, the electrical impulse that I'm getting from this lower float switch, and put it in two different places now. What I want to do, what I want to do is keep it in the original place I had it, which was up here. But I also want to terminate that. So I'm just going to do this. I'm going to put a contact in here, and I'm going to call it R4-2. Then I'm going to consider whether it should be a normally open or normally closed. At this point, this is where you stop and you say, okay, what's happening, dude? Well, actually, at this point, you've already filled it. It's coming down. It's empty. So when it gets empty, what you want to do is you want to terminate all of the holding circuits. Plus, you want to actually stop energizing this. You want to turn that off. How do I turn that off? Like terminate this holding circuit. Sorry, I terminate. Pardon me, I got that wrong. No kidding. I get confused too. It's not a simple thing, but it takes practice. Okay, good. So here we go. So what I want to do is this guy over here, this is being held, right? And it's holding this energized. I want to de-energize this. So I'm putting a termination contact here. I want to decide whether that termination contact is open or closed. So which event is doing that? Well, the fact that it's empty. Because when it's empty, that's when I'm going to turn this off. So when it's empty, this becomes closed. Okay. So when it's empty, I want this to open. That makes sense? Let me go there again. When it's empty, I want to terminate this. I want to terminate this holding circuit. I want to de-energize this when it's empty. So if it's empty, okay, so it's empty, I want this to become open. So should this be a normally open or normally closed? Think about it. When it becomes empty, that closes. Should this be a normally open or normally closed? Because I want it to become open. So what have we got? Who's, yeah, wait. NO or NC, normally closed. Cool. And you're right about that. So this should be a normally closed. But what you need to do is you have to think about it. What happens when a contact either opens or closes? And what do you want to do with that information? Well, in this case, the event is the liquid goes below this. So I know that that becomes closed because it's normally closed. It goes into its normal state and it closes. And when that happens, I want to shut this off. If I want a contact to open, I'm going to use a normally closed because as soon as this happens, that's going to energize. So this will then become active and it will become open. That's why I need a normally closed. Now, I'm not going to go any further with this. Next week, we'll actually, in lab 5, we're going to do something that's a little similar to this, but we're going to have a timer. So it's going to come up to here and it's going to wait a certain amount of time, and then it's going to empty. So get this in your head because we're going to build this in lab next week. Yeah, it's coming. You're going to need 1, 2, 3, 4 relays to build this, actually, plus a timer. So we'll talk about the timers later. But what's happening here is that you're actually going to have a normally closed float switch. You're going to simulate this with a toggle switch, and you have to make sure that when you toggle it down, it's closed. In this case, with the other float switch, when you toggle it down, it becomes open. So you have to make sure you orientate your switches one way or the other. I'll talk about that in the lab video. The other thing is that we're going to put a timer in here to do this. But we've walked through this, and what I need to do is just stop and start from the beginning, follow the whole thing, and then I'm just going to say that's it for this because this is enough, okay? And then you can watch this again. Okay. Always start with I'm not doing it. No events are happening. None. So, well, actually, in this case, one of the events happening because the tank is empty. Okay. So the signal that the tank is empty is actually happening. Okay. So by the way, I may have to change a couple of these. Yeah. See, dude. Remember the event? It became low, came through my R2. I put that here, and I put my R2 here. So I have to redo these and turn them into R4s. Again, I have to think about what I was doing. Okay, when this became closed, it was low, and this became closed. Okay, so I'm going to leave that. Actually, I'm going to leave both of these because I haven't changed the nature of this contact. It's still a normally closed. So all I'm going to do is I'm going to rename these R4 and R4. Now, I had an R2 somewhere else. Oh, R2-1, it was here. Okay, that's fine. So, okay, see? I mean, I would have found that out as I was going through it, but I kind of went through it in my head before I started. But this is what you do. When you design your circuit and you're wondering if it works, there are two things you can do. One is, actually two things you should do. One is just sit and just do this process I'm about to do with you, which is kind of walk through it. The other is to draw it on Automation Studio and actually test it. So Automation Studio is, you've already heard about it in the lectures. If you haven't, you will. So here we go. I'm going to start with nothing. I have not pressed the button, and the tank is empty. So therefore, what's energized, what's active, what's open, what's closed? This guy is open because the fluid's down. This guy is closed because the fluid's down. And all of these contacts are open, and everything else is not energized or on because that's open, that's fine. Actually, this is closed. No, this is actually open. When the tank is low, that is open. Ooh, this creates a whole problem. Another problem in my design. When my tank is low, this is going to be open, so I can't even fill it. So what do we do there? Well, we're going to have to put override in here, or maybe we can put something else. So for now, what I'm just going to do is, there are other ways to deal with this, but I don't want to get any deeper into this, but I've just found a flaw in my design. That's what happens when you go through. So what I'm just going to do is I'm just going to go here, and I'm going to put a switch, and I stuck it in. You're actually supposed to draw like this, and I'm just going to call that my override. Override. Okay, good. So that's my override switch. So I'm going to close that so that I can start it. Once I start it, then I can turn this override off. Okay, good. So I turn my override off. I close this. By the way, when it's empty, this is energized. So therefore, this is actually open. Sorry, no, my R4 is open. This is open. That's open, but that's fine. I got that covered. I press play. So when I press play here, I do have current going through here. This energizes, that becomes closed. This becomes closed. My R4-2, in this case, what's going on is that this actually came from my R. This should come from my R. This should stay from my R2. Because watch this. What's going on is that the reason that I need this to come from here is that this signal is going to disappear if I put it directly from there. It needs to come from here. So I'm going to put that in my R2-2. Okay, good. So now, when it's low, that's closed. So therefore, that's closed. So therefore, this is energized. And is this guy open or closed? Well, in this case, because this is open, this is not going to energize. So that's in its normal state. Therefore, my current can go through here. It latches onto it, or there's a memory latch or a holding circuit that remembers this event. The event was temporary because as soon as the liquid comes on, because the pump comes on, the motor comes on, because that's closed and that's closed. So the motor comes on and it starts to fill. Now, as it starts to fill, it goes above this. This becomes open, and that's okay. This de-energizes. That goes back to its normal state. So I can open this switch again. This guy goes to its normal state, but it's okay because I'm a holding circuit here. So this remains energized. So this remains closed. So that's true. And this is closed because this momentary signal is held here too. So that's still energized. So my motor comes on. My motor stays on until the next event. The next event is it fills. When it fills, this becomes closed. This energizes. This guy becomes open. It de-energizes this, and it holds on to this. Because this is a momentary event. The liquid comes up and it starts to go down. It's okay because I'm holding on to this. So that energizes, it closes this, and it opens this. And then my fluid starts to come down because it also energizes my solenoid. So my solenoid valve, the drain comes on, opens up. Now this starts to come down. When it gets down to here, this becomes closed again. When it becomes closed again, because I've opened this, it's going to open this. It's also going to open this. And where's my other R4? This. 1, 2, 3. Good. So this guy is going to become open. This guy, because that close is already open, so this guy is already de-energized. So what's going to happen now is that as soon as this closes, everything's going to shut off. Everything will shut off, and that will de-energize, and then I'm done. Now, we know that if I press play again, if I press start again, it won't fill. I've got to close this. So we can maybe call that a supervisor switch, or maybe, some kind of a checker, that says, okay, we're ready to start this process again. Yeah, I'll close the switch, and then, it'll tell you, yeah, you can go ahead and do that. So what you need to do is watch this again. Essentially, this is all about holding circuits. And what we learned from this was that the process of design is dynamic. We're constantly going to be changing our design. So when you're doing this, don't even try to do it pretty, because you're going to be erasing it, right? So use a pencil and a blank piece of paper. Don't ever do anything on line paper, dude. It's just, especially because it's going to get really complicated like this. The lines just boggle your mind. Just throw all your line papers away. Never use them again for engineering. Do everything on blank. So we know that the design process is very dynamic, and you have to erase stuff all the time. And you have to think about whether it's normally open or normally closed. We study the fact that events are the things that actually drive our system. You have to think about event programming. Events are translated into electrical impulses from switches or sensors. In this case, we're using switches. And we have to think about whether or not we want that impulse to be high if the event goes away, or high if the event comes in, or vice versa. Maybe it'll go low when the event happens, or go high when the event goes away. So I think that's it. I think all we need to do is just say, okay, well, that's fine. I'm going to study this again and wrap my head around this. Before you actually watch this video again, I hope you go back. If you haven't already watched the 2 videos on Lab 4, just stop everything and go watch that again, and then watch this video again, kind of with a fresh mind, and you'll have a better understanding of what we just did once you watch those 2 videos. So I think that's it. I'm just going to field one question. Okay, question about design process. Should we formalize our event programming as sort of a project specs before doing the ladder logic? So this is a good idea. So the question is, should we actually kind of list all of our events? And that's a really good idea, yes. You need to come up with your own kind of processes, your own thought ways, your own thought patterns, or your own kind of methodology to making all of this happen. So we know that the basic structure, the basic tools that we're going to use are events, right? And we're going to use switches or sensors. In this case, it's all switches, and they're going to give us electrical impulses. And then we're going to use relays and holding circuits. And how you want to organize and put all that together, you'll find your own way of doing that, and that's fine. So I think it is a good idea to write all your events down first. And I actually have, what we're going to do in lecture in week 11, I think, is, we're going to go through the process of how you actually do ladder logic design. And essentially what you do is you write down all your events first. Write down all the events first. And then from there, you try and figure out whether they're momentary or they're continuous. So that is a good part of the process where you can write all the events down, because you're going to use them to build your structure. You have to think about, if one event is happening, is another event happening? Does one event affect another event? What's going on? Well, for instance, let's say the temperature of the liquid went up. Okay. Well, the temperature of the liquid only can go up if there's liquid there. So one event is tank gets full. The other event is tank reaches that limit of temperature. So we know that they're actually dependent on each other. So we can't have the event of the temperature going up before the liquid's there. So those events are really what we're building all of our design process about. So good questions. Okay, I'm going to let you guys go. Thank you very much for watching. Again, go and watch those videos for Lab 4, and then watch this again and try and wrap your head around this, because essentially this is part of what's happening in Lab 5.